We're going to go through some of these questions that were asked during all the presentations. And actually, one of the first ones that I'm going to say, because you guys, all you presenters might have a picture handy, but somebody asked to show an image of cross stitching.
Kim, this is Linda. I don't, but I've got a picture of cross stitching.
And thanks, Linda, for bringing those pictures up. So for whoever asked, I hope that's what you were looking for. Start at the top. Mike, question for you. Can you tell us what the expected life of a partial depth patch is in Indiana?
I talked to our pavement engineers and we were shooting for 8 years. That's probably very conservative. I know MnDOT has maybe 15 to 20 years on some patches. I don't want to overstate, but 8 years is what kind of a conservative number we've been using, but I think the patches should last longer.
Does anybody else have anything to add to that one? Partial depth patch life?
John Roberts here. I can tell you that we've seen partial depth repairs, certainly last the life of the pavement itself when properly placed with, quality materials and so on and so forth. So really, as Mike had mentioned during his presentation, it's all about the install and the materials. Properly done, partial depth repairs can last as long as the pavement itself.
Thanks, Kim. Thank you to John Roberts. So here's a crack. Here's the device. So you can see the angle of the drill set up on either side, and then the final result. So you can kind of see the tie bars that go across the crack.
Another question for Mike. Do you saw cut for partial joint repair? And I'm not sure if this person's talking about the saw cutting the joint or what exactly.
If you're talking about saw cutting for the initial removal, no, that's got to be done with a mill. The roughen texture is a big part of the bond. As far as sawing to reestablish the joint, we will allow it on the longitudinal joint. We do not allow it on the transverse joint. And again, the reason is you've got to ensure compression relief across the transverse joint. And it gets a little bit difficult because the variable depth across some of those joints to guarantee you're sawing the full depth of the transverse joint.
Kim, if I could expand upon Mike's explanation there, the original method for doing partial depth repairs was to saw cut the perimeter. MnDOT came through with the milling removal procedure, which is widely successful, widely accepted across the U.S. But oddly enough, there still are a few partial depth repair materials that, as part of the installation process, require vertical saw cut edges. We don't see them in use very often, but there are still some specifications and products that require saw cut perimeter. So that to the audience here today, I'd recommend that you make sure you understand the requirements of the product that you're using as a pour back material before letting the job out.
Good point, John. Thank you for adding that.
This is John Donnie. I just wanted to echo the John and Mike's comments about this. We naturally gravitated. We started out with a sawed perimeter about 20 years ago in our partial depth repair specs, and just through trial and error, we found out that the milled surface did provide the better texture. You could sandblast the edge of a saw cut perimeter for partial depth repair, but you're still not going to get the same, three-dimensional texture, I guess, that you would from a milled surface that really solidifies the bond with the patch material.
Okay, so a couple questions for John Donahue. What is the typical short, in quotations, patches that does not require dowel bars? And I think that you kind of talked about that around 20-25 feet, but I don't know if you have something else to add there.
You mean mid-panel dowel bars? I mean, any patch is going to require dowel bars for load transfer. I did say that the short, well, okay, first of all, yeah, we use a 25-foot maximum length for a full depth repair where we don't require a mid-panel dowel basket and saw joint. Like I said, somebody else could prefer something shorter than that, and I wouldn't argue against anyone using a shorter maximum length. If they were referring to tie bars, we're not generally, unless it's about 30 feet or longer, we're not going to bother with tie bars to reestablish the longitudinal connection.
The only other thing I can maybe gather from this question is if we were thinking, or if the person asking was thinking, if you're doing like one panel at a time, do you always require dowel bars with that panel replacement? Or maybe even a half panel replacement? Would you require dowel bars too?
It's a good question. If you're just doing a half panel replacement, I would, at a minimum, put probably 3 bars in the wheel path. So I'd at least reestablish load transfer across the wheel path for narrow or full depth repairs.
Next one is for you, John. It says, is it impractical to think that a full depth repair should last the remaining life of the pavement?
Depends on what the remaining life of the pavement is. If you're, say, 30 or 40 years, yeah, there's a good chance. It should. If it's a failure that occurs relatively early in the life of a pavement, say within the first 10 years, you can, if you do a good enough job, I think you can expect upwards of 20 years or so out of a full depth repair. But again, it's simply not the same as you would get from a monolithic pavement where you have the aggregate interlock at your saw joint locations and longitudinal joint. You're losing that, and that does, I believe, maybe incrementally, but I think it does make a difference over time.
Yeah, and I do believe too that good construction practices have a huge part in that as well. So Kurt, looks like there's a couple questions for you during your presentation. When joint resealing, how do you ensure that slurry or debris from the recutting or the cleaning operation is not pushed into the crack, especially below the initial cut, which would restrict future expansion movement?
After the sealant has been removed, there is a water flushing operation that's done, and a lot of that material is tried to be removed. The good thing is that typically this resealing is going to be done in warmer times of year where that opening beneath will not be that wide or that extensive. So there shouldn't be a lot of opportunity for a lot of the bigger materials to work down there. You're not going to prevent all of the slurry and stuff, but I don't think there's really much of a concern about any of the bigger materials working their way down into the deeper recesses of the joint.
Another question is, are there any situations where one type of joint sealant, either hot poured or silicone, should be avoided?
I guess the one that comes immediately to mind is where you may be subject to fuel spillage, and many of the hot poured, or most of the hot poured, are going to be not good candidates for that kind of an application. So whether if it's in the bay of a fuel yard, if it's on an airport where there could be subjected to fuel spillage, you would not want to use a hot poured material in that sort of an application.
Thank you. I hadn't even thought about that. Last question for you, Kurt. How long does a joint sealant typically last?
All right, I threw out just some rough numbers. Typically, you may hear people talk anywhere from maybe 4 to 10, but like I described, it's not unusual though to get more than that. And with good processes, good procedures, good quality workmanship, we've seen a number of sealant installations last longer than that. And I even gave you the example of both a hot poured and a silicone lasting as long as 20 years and still going. So even though we may throw out the 4 to 10 or whatever it is, it's possible to achieve longer lives with proper installation practices and procedures.
There's a couple questions here for Linda with Dowel bar retrofit. So the first one is, when using epoxy coated dowel bars in a dowel bar retrofit, does it matter if the ends are coated?
Short answer is yes. You've got to make sure that you don't have any corrosion happening. And it's again, that was a kind of a discussion everybody had is, the water comes in at the joint or crack and it doesn't go anywhere, but no, water finds the end of the bar and it does cause corrosion of the bar. So absolutely, coat the bar.
Coat the whole bar, guys. And this other one, I'm not sure if you'd be able to do it or not, but they're asked, this person would like you to share a plan view for the placement of dowel bars when the joint is not perpendicular to the direction of traffic. So a skewed joint. Are the dowels staggered to stay in the middle of the joint and keep in the direction of traffic?
So yes, the dowel bars are staggered so that the slot is still centered over the joint. And so, depending on your skew, your dowel bars slots will be, when they come through on a skewed joint, they actually, if it's a full lane width saw cut, so they're doing all 6 or how many dowel bar cuts at once, the saw cut is actually skewed. So the rightmost blade is ahead of the far left blade. And so they are staggered across the skew. because otherwise you wouldn't be centered over the joint, and you really need to be centered over the joint.
Yeah, correct. The dowel bars aren't long enough to take that. So, okay, thank you.
John Roberts here. If people, I would love to share a plan view, except I'm on a borrowed computer, which I already screwed up, and I'm afraid it might blow up if I try to do anything. If people are curious, they can go to igga.net, and under the resources tab, there's a series of, you have to go to DVR, but there within are plan sheets that, oddly enough, I think we stole from Washington State DOT that shows the layout. So again, there, if you're really curious, you can dig into the website, and there they exist for you.
So there's a couple of questions here for you, John, too. How does diamond grinding affect lateral drainage?
The drainage of any given pavement is really dominated by the slope of the pavement more than anything else. The grinding texture itself is typically a 1/16th, maybe an 1/8 of an inch in terms of the lands versus the bottom of the grooves. And what we achieve here with the grinding is a increase in macro texture, which, like tire tread, provides the motorist with a situation where the tire can squeeze the water out. What we're looking to do is provide area for the water to be displaced. We're not necessarily trying to cut channels like you might with a transverse tining, assuming that would take water off the pavement surface. That's not the case. What we're doing is providing increased macro texture, which allows water to escape and reduces the potential for hydroplaning. So that's not an issue really at all.
This next one, I believe you answered in some of your slides. They're wanting to know what the typical level of noise reduction is after grinding.
Depends what we're starting with. You can have a real noisy transverse tine, and you can reduce the noise down by, several decibels from, the loudest condition. Now, if you have a longitudinal tined surface and you diamond grind it, you might pick up 2 or 3 decibels. So it really depends what you're starting with. Irregardless, there is almost always an improvement in the noise quality, or a reduction in unwanted noise is maybe a better way to put it, when you diamond grind any pavement surface. But again, it depends. If you're really, really loud, you'll get several decibels. If you're starting with something not so loud, you'll pick up a couple decibels.
This next one is really interesting to me. It's about the cost per square yard, but this person said that the unit price from the last diamond grinding project in northern Michigan was $55 a square yard. So you did show some costs there were around like $2.75 a square yard or something like that. They're asking what the current estimated unit price for diamond grinding. So I believe that's what you had in your presentation.
That was related to an average price in the state of Kentucky over a 5-year period. The answer is it depends. And while $55 per square yard sounds, that's wow, right? That's because most of the grinding that you're going to see in the United States on an average hardness, average removal, and so on and so forth is going to range probably from $250 to $550 per square yard. So in this particular case, I have to guess that $55 per square yard was probably a very isolated, small project with bad hours, small quantities, a real hard aggregate, and a lot of removal. You know what I mean? Because all those factor into the price. The amount of removal, the hardness of the aggregate, the number of working hours that you provide the contractor, the mobilization, and so on and so forth, all factor into the price. But I can tell you, in the United States, most pavements, with a medium hard limestone or a granite, they're going to range $250 to $550 per square yard for grinding on a decent sized project. 80,000 square yards, 100,000 square yards, 150,000 square yards. You get into the small jobs, the price is going to go. It's almost like an hourly price. It's just going to depend on all those little factors. Actually,
quite a few more questions here on diamond grinding. So you're the popular one this time, John, or maybe it's just because you're at the end of the presentation. So I'm going to pick a few since we do have only a few minutes left, and I'm sorry if I don't get to all of them. This one's interesting. During the diamond grinding operation, can you leave the existing sealant in place if it's in good condition?
The answer is it depends. We've seen plenty of states do that. The outcome depends upon the condition of the sealant and the depth of placement and the depth of grind. If you're grinding real deep and you get the blades into the joint sealants, chances are you might tear them up or rip them out. If the sealant was placed recessed and you're taking off an 1/8 inch or 3/16 of an inch of pavement, you might be able to leave the seals. Ideally, if you're investing in a pavement, though, we tend to recommend, hey, go the full route and do a nice reseal on this thing and get your maximum longevity out of that pavement.
This one's interesting for the people that use or have limestone aggregate. It says, does diamond grinding work for increasing friction for PCC pavements with limestone aggregates?
The answer would be, it depends on the quality of the limestone. We have polish-prone limestones, and then we have more durable, high-quality limestones. I guess the caveat to the whole thing is usually the softer the aggregate, the less life or less benefit you're going to get from it. The upside is it's typically cheaper to grind a soft aggregate than a hard aggregate. There are some pavements that probably just shouldn't be diamond ground if you have a polish-prone limestone aggregate. And you should know that through experience by looking at, how your longitudinal or transverse tining is held up in the wheel paths, whether that wore off reasonably quick or whether it stood proud. So again, it sort of depends. But let me tell you this: there's millions of square yards of limestone pavement that is diamond ground in the United States every single year, performing very, very well.
This one's interesting, and I actually don't know the answer. So I'm going to ask this. Are parameters available for AASHTO noise modeling of diamond grinding?
That is beyond my scope of knowledge. We have seen a couple of projects that had noise targets associated with it, which is very subjective and very difficult to estimate as a contractor, certainly. But to my knowledge, no. And if there are, in fact, anything of that nature, I'll apologize right now, but not to my knowledge.
Yeah, I didn't know the answer to that one either. So any other presenters, do you guys know if there's any noise modeling for diamond grinding? I don't know of any.
This is John Donahue. There's about 3 or 4 AASHTO standards that address noise modeling, but not specifically as related to, I guess, the effect that diamond grinding has in mitigating noise. So it's not directly or not to that level of detail, no.
And I'm going to ask one more question for Linda. This is a question on dowel bars, foam spacer. How important is the foam spacer placement of the dowel bar?
So the foam core board needs to be, ideally, again, it's on the middle of the bar, and it needs to be aligned with the joint or crack. Is it how much does it move along the bar on either side of the joint or crack? I've seen it be off by less than 1/2 of an inch, and you get spalling. And so I would say, make sure it's as close as you possibly can get. Aligned with the joint or crack.
And so this person asked another question about the coating of the ends of the dowel bars, but I think what I would rather do is take a look at IGGA.net under the dowel bar resources, like John said, because I bet you there's some plans there, and that might lead you to some of your answers for the person that's asking those questions. Again, thank you to all the presenters for doing a wonderful job presenting. It was very informative.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.